So we're going to re-hit the idea of functions. Last time I did it, or the first time I did it, I think I called them modules, and that made people go down and read chapter 12. The idea of a module is a little bit different. A module has both data and functions. In other programming languages, they could be called classes, and you can make classes with this language as well. Turtle, for example, is an idea of a module. You do import turtle, and you get a whole bunch of things. You get the ability to, make a turtle, and then to give it calls and have it run around. Now, we're not doing anything that complicated. We're just writing functions. Functions, at this point, that perform some discrete task that you may want to call over and over. So the way you define a function is with the def keyword. Use def followed by the name of the function. If it needs to accept any data, you can put something between the parentheses. That'll be a variable that accepts data that's passed to it. And then a colon. And everything after that needs to be indented. If it needs to return a value, if it's a quote fruitful function, it has to have a return statement. If it doesn't need to return a value, you can leave the return off. And we'll give a couple of silly examples of those. So let's see. Define Joan Jett. What does she do? She sings, "I love rock and roll." Then she sings, "Put another dime in the jukebox, baby." Then she gets tired of singing, so she walks off the stage. Return. This function doesn't really need the return statement because it doesn't have anything after it. We're not returning a value. This is what's known as a void function. Void functions don't return values. So we could skip the return word. Alrighty, now we need somebody else to sing to us. Huey Lewis. He's going to not do anything, but he's going to return "The heart of rock and roll is still beating." So this is a fruitful function. It returns a value. Down here underneath our two functions, first let's call Joan Jett. I'm just going to say this is rock, because that's what we do in this class all day long. We rock. Here we go. Alright, so I run in and it says, "I love rock and roll, put another dime in the jukebox, baby." It did that because I invoked the Joan Jett function. I like her so much, I'm going to call her back for an encore performance, and she's going to do the same song 2 more times. Alright, and we paid big bucks to have Huey Lewis come, but he hasn't done anything yet, so let's call him as well. Now that didn't change anything. It just still prints the lyrics to "I love rock and roll." Why? Because Huey Lewis, that function, doesn't have any print statements in it, but it returns a value. That means that we have to catch the return value. The quarterback throws the ball, we better be there to catch it. So we're going to do this. A is equal to Huey-Lewis, and then print A. And that time it did print something. It printed the heart of rock and roll is still beating. So this function did return a value. It returned a string that we were able to print out. You can make functions that'll return calculations, you know. Make functions that'll really calculate whatever, you know, the interest rate or the amount saved or, you know, that kind of thing. Let's go see other examples of what they have to say. Area. The area of a circle could be defined as pi times radius squared, which they have radius times radius. Now that's just an area of a circle. I don't know why we would assume that everything is a circle. Let's go ahead and write a couple of area functions. Define area underscore circle, and it takes a radius. So the area of a circle is pi. I'm going to do what they did and just call it 3.14159. We could import math and use math.pi times radius squared, which we could do as radius times radius, or we could do radius star star 2. That means square the value. And then return A. Now let's do the area of a square based on its side. So if you have a 2 by 2 square, it's got an area of 4. So the area is just going to be the side times the side. Or I could do side star star 2 to make it look like this one. And then return that. These functions did not accept any parameters. They didn't have anything between the parentheses. So when we called them, we didn't put anything there. If we did, it'd probably be an error. I'm going to test it out. I'm going to put something in between the parentheses. Don't do this, because it's probably going to break it. And it blew up. It said, JoanJet, hello. JoanJet takes 0 arguments, but 1 was given. This is what's known as an argument. When you're sitting there on the calling end of it, it's called an argument. When you're sitting there inside the function itself, it's called a parameter. But he doesn't have any parameters, so he can't take any arguments. So that was bad. Alrighty, now let's call our area of a circle function. This is not going to be right, but it's going to be our first stab at it. I'm going to calculate the area of a circle. This is not going to do the trick. Alright, there's a couple of things wrong with what I just did here. What might one of them be?
You didn't define the radius?
Right, I need to pass a value in. And so let's do that. The area of our circle is 10 whatevers, 10 units. Now I run it. And all it's still doing is singing. It's not doing anything.
You have to call back.
Yeah, I need to store it in a variable so I can print it out. AC for area of circle is equal to that. And then print the area of the circle is AC. And it worked. Do the same thing, except call the area of the square function. So do 2 lines that call the area of the square and print it out. And you get to pick the variable name. I don't care if you use AC, but since that stood for area of circle, you might want to use something else. Alright, I'm going to take a shot at it. I'm going to call it AS for area of square. I could be choosing better variable names, and when I type AS it comes up as orange. That means it's a really bad choice for a variable name. So I better call it something else. Just how about the word area? Area is equal to the area square, and I'm going to pass in a different number. Doesn't have to be 10, but why not? Print the area of the square is area. And that's true. If you have a square with a side of length 10, its area is 100. So this is a fruitful function. This is a fruitful function because it returns a value. So is this one. You won't always have fruitful functions. We did a flower function that drew a flower. It doesn't need to return anything. It just needs to do it. So, we'll come down here and kind of map out a problem. Write a function with the name of inverse that accepts a parameter named x and returns the value 1 divided by x. I don't think that's actually what inverse means. Reciprocal? What is it called when you put a variable under 1? There's a better term.
Yes,
It's reciprocal? Okay, thanks. Yeah, okay, so thanks. Let's just call it recip. And then write a function with the name of square that accepts a parameter named x and returns x times x. All right, I want y'all to work on those rather than me just start typing them. So go ahead and do those. Then I'll come along and type anyways. Alrighty, I'm going to do that recip one first. How do I start it off? Yeah, DEF, recip, then what? Parentheses x, and I need my colon. Yep, a is equal to 1 over x, return a. That would do it. The square one will be very similar. Define square, parentheses x, colon. A is equal to x times x. Return a. Now you may have done it slightly differently. You may have chosen a different variable name other than a. Or you may have done this, which is also legal. You may have just done take that out completely and make it say return 1 over x. That's also valid. I like storing it in a variable and then returning it, and the reason I like to do that is because if I get stuck as to why it's not working, I can always go in and add a print statement, debug a equals, and print that out and find out what it returned. Then I can come back and remove that. Whereas I can't really do that if I do it all in one swoop like that. So let's use those. I is equal to 10. I is equal to the reciprocal of 10. Recip I. Then let's print I. And then for grins, why don't we square that? Now that'll be the square of 0.1, which would be 0.01. That's not too interesting. Anyways, okay. X is equal to 2. X is equal to the square of x. Print x. And these look same to me because the reciprocal of 1 over 10 is in fact 0.1. And 2 squared is 4. We could make this function break by passing in 0 rather than 10. I is equal to 0. I is equal to recip I. Let's see what that does. We're trying to do a divide by 0. Usually that causes a program to stop running. Yep. It says 0 division error. So what are the sort of things that you can do with a function? Well, in a lot of these problems, we kind of do the same sequence of steps. We print a message, we get the input, and then we convert it into an int or a float or something like that. You could put that into a function and have the function do any required error checking that it needs to do. If you're letting them type in an age, don't let them type in an age less than 0. That kind of thing. Let's write a function that will accept input in the form of what we have been doing, where we display a message. Now you don't necessarily have to type this, but this is what I'm thinking about making it do. Print a message, input, and then convert to a float. That's kind of the sequence of steps I want this function to do. So what would be a good name for a function that got a value and returned a float? There's no wrong answer, except that one. No, I'm kidding. Input float. I didn't hear anybody say it, but here we go. Input underscore float. And we're going to let them create the message. They're going to pass the message in. So we will print that message out. We will then get some input. F is equal to input, and then we will convert it into a float. F is equal to float F. Then you can do things like this. X is equal to input underscore float. What is X? And Y is equal to input underscore float. What is Y? And Z equals input underscore float. What is Z? So we are in effect replacing these three calls here with just one call. Now 3-to-1 ratio isn't that great, you know, but it's pretty nice. Truth be told, we could have compacted all of these three things down into one line as well. So this isn't a perfect example. But what if this thing was written to be a little bit more complicated? What if they typed in a non-numeric value? If it had letters in it, we gave them an error message and asked them to do it again. That could all be handled inside of input float so that this code down here didn't even have to sweat it. It knew that whatever was passed back was a number because any non-numeric input had been handled by our function. So let's just print x, y, and z since I can't think of anything better to do with those numbers right now. What is x? 10. What is y? 20. What is z? 30. None, none, none. Alrighty. I made a big mistake. Anybody spot it? I don't have a return statement. Yeah, so this is a void function, and a void function in this language returns a none. In other languages, they return void. So I needed a return f here. Now this language supports something that a lot of other languages, in fact this is the only one that I've ever seen it, works this way. Do this. Define silly and return 1, 2, 3. And then do x, y, z equals silly. And then print again x, y, z. X is 10, y is 20, z is 30. What is it doing? The return statement is actually returning a sequence of values. And the 1 is getting stored into x, and the 2 is getting stored into y, and the 3 is getting stored into z. Now that's really weird, and don't think that you're going to find this in other computer programming languages, because like I said, this is the only one that does that. Another oddity of that. What if you do this? A, B, C equals 10, hello, 3.3. Then if I print out A, B, and C, it's going to print 10 and hello and 3.3. You know, so if I do print A, that's 10. Print B, that's going to be the word hello. Print C, that's going to be 3.3. That's just weird syntax. It does have one nice effect, though. Say you have two numbers and you want to swap them. Here's how you do it in most languages. Say you have x. I'm going to make this a comment. Say you have x and y. Write code that will swap those values, those variables. Here's how you do it most of the time. You create a temporary value. You do temp is equal to x is equal to y, and y is equal to temp. And you can probably see why you do that. Like if I want y'all to swap your computers, well, if you threw your computers at each other, they bang in midair. So you have to give one me, temp. And then she can give you hers, and then I can give you back, like that. So that's how you do a swap in any sane language, but Python in this case is a little bit funky. We can do this. X, y is equal to y, x. That swaps them because y gets copied into x and x gets copied into y. I never take advantage of that, but you can. So fruitful functions are not limited to returning just one value. They can return multiple values. In other languages you can do that, but you have to return it as a structure known as an array or list. Yes, sir?
Every time I return, I think I'm still tagged, like further than even my f equals.
Well, we have to fix the tabbing ourselves if it's not being kind enough to do it for us. Well, in that case, it's okay. Yeah, I don't know what it was doing there. This is just to illustrate silly stuff anyways. All right, so we know what a fruitful function is. We know how to write them. If I give you a little assignment like write a function called this that does that and returns this, we can do it. Let's go ahead and stop.